What do both of these terms have? Just an x. So we factor that out. When you factor it out, it's like dividing. What is x squared divided by x? X. You just subtract those exponents. Minus, what is 6x divided by x? And that would just be a 6 because the x's cancel. And you can always check yourself. How? Checking to multiply it back out and see if you get the original problem. If I distributed this, x times x is x squared. X times negative 6 is negative 6x, and that was the original problem. Alright, so number 2. I have two terms. What do they both have? X to the second. You have to take out the smaller exponent. So when we divide that, x to the third divided by x to the second. If you subtract those exponents, that just leaves you with 1x, and we have the y. On this one, those x squareds will cancel, and it's just the 9. Number 3, we have 3 terms, so we need to know what they all have in common. So looking at the numbers first, 8, 4, and 12. What can divide all of those? We will take out the 4. And then we look at our variables. We have x to the third, x to the second, and just an x to the first. So we take out the smallest, so that's just an x. When you factor it out, it's like dividing. So 8 divided by 4 is 2. X to the third divided by x. So 3 minus 1 is x squared. This one, if I take out my 4x, 4 divided by 4, that cancels. X squared divided by x is just x. This one, 12 divided by 4 is 3, and those x's cancel. Okay so far? So number 4. 2 terms, 10 and 25. What can we take out of both of them? Okay, looking at my variables, I have an x to the third and x squared. So we take out the smaller, so we take out x squared. With our y's, I have a y to the first and a y to the third. You take out the smaller, which is just y. So factoring out is like dividing. So 10 divided by 5 is 2. X to the third over x squared. 3 minus 2 is 1. And those y's cancel. 25 divided by 5 is 5. X's cancel. Y to the third divided by y. 3 minus 1 is 2. Last one, 3 terms. What do they all have? And x to the second. So 14 divided by 7 was 2. X to the fourth divided by x squared would be x squared. 35 divided by 7 is 5. X to the third over x squared. And what happens if you divide something by itself? So factoring is like doing the reverse of our multiplication. And that's what we are working on Friday. Are there questions on any of those? Okay. So what I want you to do now is look at the start of the next notes page. And there's some warm-up questions. So it's asking you to multiply those things out. So I'll do one with you and then we'll have you guys finish it. So if I wanted to multiply these, we have to FOIL. So x times x, x times negative 4, 4 times x, and 4 times negative 4. Then when you combine like terms, what happens to negative 4x and positive 4x? And we're left with x squared minus 16. I want you guys to multiply out the next two. Okay, so what did you guys notice on every one of these? Okay, our final answer had a subtraction. How many terms did we end up with in our final answer? Only 2, because what happened when they canceled out every time. Look at the original parentheses. X plus 4, x minus 4. 5m plus 1, 5m minus 1. 2a plus 3b, 2a minus 3b. What was the difference in those parentheses? Yeah, it was the exact same terms except one was adding and one was subtracting. And when we did that, the final answer lost those middle terms. This is what we call the difference of squares. So if you have 2 perfect squares at the end, perfect square is something we can do the square root of. Okay, we can do the square root of x squared. If we have 2 socks, we can make 1 pair. I can do the square root of 16. I can do the square root of 9 and 25. If those are perfect squares with a subtraction in between, then we can factor it back by looking at those difference of squares. So, if you have a problem, a squared minus b squared, it will factor into a plus b, a minus b. 2 identical parentheses except one has an addition and one has a subtraction. So this is kind of a special case that we are able to factor. And just like our factoring Friday, we can always check these by multiplying it out. So we want to factor each of these. And remember, if something can't be factored, what do we call it? Prime. So if it's not something we can factor, we can write prime. So a squared minus 4. First you have to look and make sure it's a subtraction in the middle. If it's not, then we're going to say prime. We can't factor. But because this is a subtraction, a squared is a perfect square, 4 is a perfect square, we can factor it. It should go to 2 identical parentheses except one is positive and one is negative. So with my a squared, what is the square root of a squared? A. You basically put half the a's in each parenthesis. What is the square root of 4? 2. So this factors into a plus 2, a minus 2. Now, would it matter if you put a minus 2 and then a plus 2? No, because multiplication order doesn't matter, so you can flip those. If you weren't sure if you'd done it correctly, you could multiply it out. So we get a squared minus 2a plus 2a minus 4, and that turns into a squared minus 4. So we know we're right. So number 2. We check, it's got the subtraction. Both of those are perfect squares, so what would this factor into? Positive and negative. N squared would break into n. And the square root of 64 is 8. So n plus 8, n minus 8. Okay. Number 3. 81 minus x squared. So it's got the subtraction. It has 2 perfect squares. So identical parentheses, 1 plus, 1 minus. What is the square root of 81? What is the square root of x squared? So 9 plus x, 9 minus x. 5. What's wrong? It's prime. Why is that one prime? It's addition. This only works if it's subtraction. When we multiplied those out, we never got an addition there. Okay, number 7. We have our subtraction again. So that's good news. We can do our plus and minus. What is the square root of 9b squared? What is the square root of 100? Why don't you guys try 4, 6, and 8? C squared minus 100. What did that factor into? C plus 10, C minus 10. And it doesn't matter if you put C minus 10, C plus 10. That's the same. All right, 1 minus 49y squared. So the square root of 1 is? Square root of 49y squared? Okay, what's the square root of 25x squared?
5x plus 7.
Doing okay on those so far? So this is all we're doing today, but let's try some that have more variables with them and make sure that we can handle that. So if I look at, let's go number 10. X squared minus 81y squared. So x squared would break into? You answer my next question. The 81y squared would break into? So we have x minus 9y and x plus 9y. Number 12. What would that factor into? 8u plus v minus v. Alright. Why don't you guys try a few more on your own so we can make sure we're good before I stop for today. Okay, let's do those evens. What do you do with the n to the 4th? Yep. So 9n squared and 9n squared. Just half of the variables in each parenthesis. And 25 breaks into 5. So plus 5 and minus 5. 49m to the 4th minus 16. What's that go to? 7m squared plus 4, 7m squared minus 4. 4p to the 4th minus 25. Plus and 2p squared minus 5. Alright, 64n to the 4th minus 9n squared.
8n squared plus 3.
Okay, and 8n squared minus 3. Last question of the day. A number 15. It has the minus. 4c squared would break into what?
Oh, it's prime.
Why?
Because what's the square root of?
Exactly. So this starts out like a problem we could do. 2c plus, 2c minus. But can we do the square root of 5? So we would call this one prime. So things that can make it prime is if it has an addition sign, or if one of those terms is not a perfect square. So I have a handout for you. We are not doing the entire thing. I want you to do 1 through 12.